This video is about analysing light curves for the HOYS LCO Observatory project. It's the third video in the series. In the first two videos, we looked at how to take the images using the LCO telescopes, and then we covered processing the data on the HOYS server. Now we're going to have a look at the light curves of some of the stars in the target objects. So as before, you can go to the HOYS server using the link on the HOYS website, and in this case there's no need to log in because the light curve data is publicly available. Click on light curve plot and this screen will come up. Now we need to enter either the ID of the star or its coordinates, and then we can extract the data about it from the HOYS database. So let's choose a nice example in IC 1396A, Elephant Trunk Nebula. This is one of the HOYS target areas. So we'll enter the ID for a star, the 2 mass one there. We'll check the type of input as name, and we'll set a search radius of 5 arc seconds. Then click on search. It can take a while to start with, but it can also get quicker after the first few times. So these are the stars found in that 5 arc second area. The top one has the most data points, so that is the one that we're probably going to be looking at. On the right hand side you can see the median magnitudes in each of those filters. So click on the top link. And this is the light curve displayed. So up at the top there's a toolbar with various functions to help you to view the data differently. So have a play around with those. It doesn't affect the data itself. It just allows you to zoom in, move it around, take snapshots, etc. We can also select which filters are displayed. You can choose which data points are displayed by clicking on the appropriate filter and deselecting it or selecting it again. And each dot is a data point for each filter. On the left hand y-axis is the star's magnitude, and on the x-axis there is the date and time in Julian date format. If we click on the enable error bars checkbox and update graph, then each data point will show an error bar. And at some point we can download the data used to create that graph and process it in an external application, and we will cover that in another video. So let's zoom in a little bit on the light curve. Let's deselect all the filters apart from the eye filter, the black one, and using your mouse drag a rectangle around about the adjusting part of the light curve. And this will zoom in on the light curve, and now we have a clearer view of the outbursts of the star. You can see on the left it had an outburst about a year ago and is currently undergoing another outburst. This is the object in the Elephant Trunk Nebula. And we can add in the other filters to see how the light curve behaves. So let's have a look at some of the features. We've enabled the error bars here. So you can see that some of the data points have very large error bars, so you can probably discard those. Many of the outliers as well and spurious points, they can be ignored too, not part of the curves. It's unlikely that these are specific real data points. Sometimes there are gaps in the data, and this is sometimes when the object was not visible or perhaps when the object was not being monitored. And fainter blue data is often less clear and sometimes less accurate as well. Not all light curves are as clear as that one. Here's one in our target area, IC 5146, and this is an emission line star. Putting that identification into the light curve plot brings up this light curve. There's a lot going on, but it's not very clear at this level. So let's dig down a little bit. So each of those clusters is showing some short-term variability, but there are also many spurious points. Looking at the red filter, there also appears to be some long-term variability, and there's a trend getting fainter from left to right. I should say that before any of this data is used to be published, there will be further calibration done, and that does tend to remove many of the outliers, many of the spurious points. Here's another interesting star. This one's a carbon star. It's a giant star. It's very red, so the blue filter is often too faint, and the red and infrared filters are often too bright and saturated, so the green filter is the interesting one here. So digging down a little bit, we can see there's quite a lot of structure in the light curve there. And one more interesting star. This is a giant star with long-term variations, but also short-term variations as well. It's just outside our target area, IC 5146, and it's not actually even in the cluster itself and may in fact be a background star, but it certainly has a very interesting light curve. So there will be a list of objects from this video on the website next to the video, as well as a few other interesting ones you can have a look at. But we do encourage you to find your own stars and put those into the light curve plot. So how do you do that? Well, the answer is Simbad. Simbad is a massive online astronomical database that you can search. You can search by identifier, by coordinates, or just a general search. And there's massive amounts of information in there, far more than you ever knew you needed. So looking at the second star we looked at in Simbad, this is the information that will come up by putting in that ID. It shows you things such as its coordinates, spectral type, brightness in the individual filters. It also shows you a little image showing the star in the target area. You can zoom in and out of that with your scroll wheel on your mouse, and we can see that it is within the Cocoon Nebula. If we click on the 2 mass checkbox, then that will bring up the 2 micron infrared survey, which will show you the star cluster without the nebulosity. So how do you find interesting stars in one of the target areas? Well, here we've searched on IC 5146 and Simbad, and above the image view there's a box where we can select a radius of say 20 arc minutes here, which is about the field of view of the LCO telescopes, and we click the Query It Around button, and that will bring up all the objects in that area around the target object. And here we can see there are 895 objects found. Now we want to look at specific object types, so click on the up arrow of the object type column, and that will bring the data in descending order. So now at the top we can see all the young stellar object stars, Y star O. We can also look at the EM star objects, the emission line stars as well. They're also interesting, and these are things that we look at in the HOYS project. The star does need to be bright enough to be in the HOYS database, so using the V magnitude as brighter than say 16 is a good starting point. Some of the other stars there would not show up as they're too faint. So we'll copy the coordinates out of Simbad and paste it into the input. We'll check the type of input as coordinates. We'll choose the units as hours and degrees because it's right ascension and declination. And the coordinate frame we're showing as ICRS. And again we'll set a radius of 5 arc seconds. And then click on search. So 2 objects found, and the first one shows the most number of data points, so that's the object we want to look at. So click on that, and this is the light curve that will be shown. So a lot of data points for that object, there's a lot going on, but is it actually interesting? What's really going on in this light curve? So you can use the tools to zoom in, change the filters, look at the error bars. Can you see any long or short-term variability in this object? So investigate it. So we are encouraging you to do that for yourself. Search through Simbad and look through the HOYS database. find interesting objects. It's not an automatic process, so this isn't going on all the time. We'd love you to write short posts or articles about what you find in Simban and in HOYS, and then maybe we'll post them on our website and Facebook page. You'll have seen that we do publish weekly light curves on the website and Facebook page, and who knows what you might find in there. You might find something that no one else has seen. There's certainly a lot of interesting information in there. And you don't just have to look at the object that you imaged yourself. You can look at all the target objects in the HOYS database. There's some very interesting ones there. On the website you'll find the target list. Things such as the Orion Nebula, the Rosette Nebula, the Pelican Nebula. And there are some very interesting objects on there. So for each object of the target set, in the target list, there is quite a large variation in the amount of data we have. For example, the Orion Nebula, M42, we have lots of images in the database, but it doesn't go very deep, not very faint. But what that does is it means you can explore the brighter stars really well. And this is T Orionis, and there's some very interesting variations there. So that's it for this video. In future videos we'll cover working with the data that was exported from the light curve plots in other applications, how to create some nice images out of the data. The background image here was actually created from data taken for the HOYS project of the Rosette Nebula. And we'll also cover the science. What do these light curves actually mean? What is going on in these young star and planet forming regions?